Right. So in this, basically today we're going to be solving Leetcode hard problem number 741, which is cherry pickup. And you're basically given an n cross n grid representing a field of cherries. Each cell is one of three possible integers. 0 means the cell is empty, so you can pass through it. 1 means that the cell contains a cherry that you can pick up and pass through. Or -1 means the cell contains a thorn that blocks your way. So -1 is the cell which has an obstacle, that is a thorn. So you cannot visit that. So our aim is to return the maximum number of cherries that you can collect by following the rules below. Start at the position 0, 0 and reach n-1, n-1. So basically start at the top left cell and reach the bottom right cell by moving right or down only through valid path cells, that is cells with value 0 which is empty and 1 which means that it contains a cherry. After reaching n-1, n-1, returning to 0, 0 by moving left or up through valid path cells. When passing through a path cell containing a cherry, you can pick it up and the cell becomes an empty cell, that is 0. So when you've collected a cherry from a particular cell, that is the cell value was initially 1, but now since you've visited it, you have collected it and the cell value becomes empty, that is it becomes 0. If there is no valid path between the top left and the bottom right cell, then no cherries can be collected and we return the answer 0. Right, so let us go to the first example. Our aim is to calculate the maximum number of cherries that we can pick up, right? So we are initially at this point 0, 0 and we need to reach this point and come back to it while collecting the maximum number of cherries that we can. The block cells are labeled as -1. So this is -1, -1. Let me draw the grid for you. So basically the input is given to us as 0, 1, -1, 1, 0, -1 and 1, 1, 1. So 1 means that we have cherries at these locations. 0 means these are empty cells and 1 again here is a cherry, and this basically cell means that this is blocked. You cannot visit these two cells. So that is mentioned in this diagram visually. You can see. So our aim is to go and collect the maximum number of cherries and visit this cell and come back to the original top left cell. So we can do this by starting from here, going down, then going down again, then going right, then going right again. Now we have collected 4 cherries in this process, right? And now we need to come back up as well. So we go left, we go up, we go another up, and then we go left. Now in this process, we have collected 1 cherry more, right? So this was during going right and down, and this is by going left and up, right? So you can go through this as well. Player started at 0, 0 and went down, down, right, right, down, down, right, right to reach this, and then it collected 4 cherries during this single trip. So now the matrix has changed to this. Then the player went left, up, left, that is left, up, left to reach the home, that is 0, 0, picking up more cherries, and the total number of cherries that we picked up was 5. That is the maximum possible. Now for the next example, we have a grid which is 1, 1, -1, 1, -1, 1, and -1, 1, 1. So let me make the matrix again. And we basically see that we have cherries placed at all these locations, but since this diagonal blocks our area, so this is basically the thorns that have been placed. So we cannot get from this location to this location, since we cannot go outer bounds as well, right? And going through this is impossible because the diagonal itself is blocked. So that means that we collect 0 cherries, right? So that's basically what we need to do. Now this problem is actually you have to think about this problem a bit. And so in order to build some intuition, I'll share this problem with you, this solution that I posted with you. So intuition is that the problem involves 2 players starting from the top left corner. So you might be thinking, how is it 2 players, right? So let me just explain to you. So from the top left corner, 0, 0 of a grid, and moving to the bottom right corner, collecting as many cherries as possible. Each player can move only right and down, and some cells may be blocked, right? The twist is you can think of it as one person making 2 trips, one from 0, 0 to n-1, n-1 and back. So to simplify this into a single traversal problem, we have imagined 2 players that are starting at 0, 0 and moving to n-1, n-1 simultaneously. They take different paths but share the same goal, that is to collect as many cherries as possible without double counting cherries if they land on the same cell. If these players, while traversing, land on the same cell. So let us imagine a person starts at the top left of a grid and wants to reach the bottom right. So along the way, they want to collect cherries, that is value is equal to 1. Some cells have thorns, that is value is equal to -1, which are not possible. Then the person must return from the bottom right to the top left again, collecting as many cherries as possible along the way, but cannot pick the same cherry twice. Now that is hard to implement directly because you need to simulate 2 journeys, that is going from top left to bottom right and again from bottom right to top left. So that is why you would need to keep track of which cherries you pick the first time. So instead of simulating 2 trips, what we are doing is we simulate 2 people starting from 0, 0 and moving to n-1, n-1 at the same time. That is the crux of the problem. So instead of simulating two trips, we simulate this, and both can move right or down. They share the same grid. At each step, they collect cherries from the cell they're on, and if both are on the same cell, we only pick the cherry once. This is the intuition of the problem. So now let us get to the approach. So this is a variation of multi-dimensional DP that we are going to see. So key ideas are, we represent both players with positions R1, C1 and R2, C2 respectively. Since both are moving step by step, we can derive R2 plus C2 is equal to R1 plus C1. So how do we reach here is because, see, in the grid, let us say we have the values, let us say this is a grid, and the starting position of this is R1, C1, that is the player 1, and the second position is R2, C2, right? Now both are moving step by step, so if this person, that is player 2, takes a step, and if the R1, C1 also takes a step, we see that R1 plus C1, that is the added value of these two, would be equal. You can also verify because this is zeroth column, this is first column, this is zeroth row, this is first row, and if you add these values up, you get the same result, right? So this is the relation that we are going to use, that is R2 plus C2 is equal to R1 plus C1. So if we know R1, C1 and R2, we can calculate C2 by rearranging C2 is equal to R1 plus C1 minus R2, right? And then we use memoization to save the overlapping subproblems so that we don't get a TLE. So the state we are going to discuss is, let dp of R1, C1, R2, C2 be the maximum cherries picked when player 1 is at R1, C1 and player 2 is at R2, C2. Simple, right? Now transitions we have, from each cell the players can move basically right or down, right? So total of 4 possible next states would be there. That is, the both the players go right. So I'll show you R1, C1 and R2, C2 when they both move right, right? So basically this is the column value, right? Let us say C1 is present here initially. So if I add C1 plus 1 and if I add C2 plus 2, that means if we have this cell, we are going from this cell to this cell, right? Since we are moving the column value, right? So both move right. This is one. So R1 plus 1 C1 and R2 plus 1 C2 both down. Now there could also be a case where the player 1 is moving down and the player 2 is moving right. So if player 2 is moving right, we take C2 plus 1 and R2 remains as it is, while for the player 1 moving right, we have R1 plus 1 and C1 as it is. So this is that case. And finally, the player 2, if it is going down, player 2, then the player 1 goes right. This was player 2 going right and player 1 going down, right? So these are the 4 cases that we can have. Now we take the maximum of all these 4 transitions, and edge cases could be out of bounds, encounter a -1, that is a thorn cell, we cannot pass that cell, and if both are on the same cell, then we take the cherry only once. And for memoization, we use a string key by the name of this to memorize the results, string key, right? Now let us go to the code. So what are we going to do is basically, we have the function solve, which takes the value n, which is the number of rows and columns in the grid, R1, C1, R2, C2, that is the player 1 coordinates and the player 2 coordinates, the grid matrix, and the unordered map string comma int of dp, right? So firstly, cherry pickup is the main function. So we passed this is the number of rows and columns. We consider this dp unordered map of of type string comma int, and we start both the players at 0, 0. So we return this max of 0 and solve. So here we take max of 0 because minimum we can have 0 cherries picked up in case the thorns are covering, as I showed you in the example of this one, where the thorns are covering the entire diagonal, so we cannot visit it. Therefore, we have 0, right? Otherwise, we take the solve, whichever one is the maximum, we take that. Now we going over to the main function. So basically, this is a function. So n R1, C1, R2, C2, and grid and the unordered map. So the base case is if we are going out of bounds, or if we have a thorn cell that is -1, that is if R1 greater than equal to n, C1 greater than equal to n, or R2 greater than equal to n, C2 greater than equal to n. That is if any of those players goes out of bounds, right? If any of those players goes out of bounds, or the grid value of any of these, that is if any of these reaches a thorn cell, so it would not be possible. That is why we return -1 E9. So minus of int max. Now base case, another base case is both the players have reached the destination, that is the bottom right cell. So bottom right cell, if we have reached, that is this cell, right, this cell. So if R1 is equal to n-1 and C1 is equal to n-1, then we return the value grid R1, C1. We only need to return, only one player needs to reach the final one, right? Now we're going to the sub problems. So if the sub problem is already solved using any of the above recursions that we call here, then we basically, that is why we use memoization string key. So the string key is, we convert R1 to string, C1 to string, R2 to string, C2 to string, and we maintain it in this format: R1, C1, R2, C2, for easier comprehensible understanding, right? So we also have a basically check here that if we are unable to find or sorry, if we are able to find the key, then we return the key. This means that if we are able to find the key in the DB matrix, then we return it, so as to avoid recalculating the sub problem that has already been calculated, right? So this would avoid TLE. So that is why I return it here. Now we have a cherries counter, which will count the number of cherries that we have picked up. So if R1 is equal to R2 and C1 is equal to C2, that is both people at same cell. If R1 is equal to R2, C1 is equal to C2, that is both of them are on the same cell. Then we take the cherry only once, because only one player needs to take the cherry, so as to avoid double counting the cherries. So cherries plus is equal to grid R1 comma C1. So we add that, and in case they are not in the same cell, then we add the values of both, right? So here basically we have only cells 1 comma 0, and we have checked already that they are not -1 above. So when we add these values, we either get the cherries, and in case there are no cherries placed there, we add the value 0, so it won't make any difference, right? So that is the logic here. Now recursive call for write down for both the people. So as I had shared, we had 4 states, that is RR, that means both the players are moving right, that is R1 comma C1 plus 1 and R2 comma C2 plus 1. This is right. Then we have down down, that is R1 plus 1 and R2 plus 1, where C1 and C2 are same. Then we have right and down, where the first player moves right, P1 moves right, and the second player moves down, that is R2 plus 1. And the second one is the first player moves, the fourth case is where the first player moves down and the second player moves right. So that is denoted by this. So these are the recursive calls. After that, we calculate the maximum cherries and store it in DP. So cherries plus is equal to maximum of all of these. So the maximum of all these 4 values we want stored in cherries, added to cherries, and we store it in DP of key. And finally, we return the cherries as answer. So that's it about this video. Let me show you whether it's getting accepted or not. Right, so I have submitted it, and yes, it has been accepted.